The writing's kind of small because you're not going to be able to see the writing from the video, but it's okay. You've got the paper in front of you. That's a repeat for some of you listening out there in the world, right? So, now, first period, when I went over this, I guess I need to just put it out there on the video and make myself completely real. I completely missed this 52 cards in a deck piece. Okay? So, I did it wrong. I saw 1 through 13. We picked a 4. And we said first period it was unlikely. And it still may be unlikely. I don't even know. But the way we did it first period, so those of you that are in first period doing this, pay close attention because we did it wrong. Okay? There are 52 cards in a deck. Now we know from our experience with a regular deck of playing cards that if there are 4, there's 4 suits, there's 4 of, there's red, hearts, red, diamonds, blue. Makes me want to say the Lucky Charms commercial. Have y'all, red hearts, yellow moon, whatever it is, pink hearts, blue diamonds, and it makes me want to say it like the Lucky Charms TV commercial. Red hearts, red diamonds, black spades, black clubs. Here we've got 4 colors. We've got red, we've got yellow, we've got blue, and we've got green. I'm going to try to write on this as best that I can so that it stays, so that it's easily saved and readable. Now, they're numbered 1 to 13. So evidently there's a 1 to 13 here, a 1 through 13 here, a 1 through 13 here, and a 1 through 13 here. Right? Are you following me? Because 13, 13, 13, and 13 is 52. Okay? This is what I missed this morning. I missed that. I overread it. I read over it. Which is why I should have done what I just did right there and circled it. Read it, reread it. Alright? So how many 4s are you going to have right here? There'll be a red 4 right here, a yellow 4 right here, a blue 4 right here, and a green 4 right here. Right? Huh? There's 1 4 in each of them, and we want a blue 4. So we did it right this morning. We did it right. We got the right answer. But I didn't break it down for them the way I should have. Okay? So, we want a blue 4. So here's what we're doing. This is theoretical probability. This is what should happen if I did this. The best way to get your theoretical probability is to, or even when they're just asking you for likelihood, is to get the probability and then determine where would it fall on that. Remember that thing that we did, our number line that we did with all the words and we glued it on there? Get the probability so you can figure out where it falls in that spectrum. So what do I want? I want a blue 4 out of all cards. How many blue 4s are there?
1.
How many blue 4s? There is 1 blue 4 out of 52 cards. And if you put 1 over 52 into your calculator and get me a decimal, what is it? It's going to be a little bitty number.
0.0.
Let's think. So it's 0.019. So we're going to round that to 0.02. Now, if I take that 0.02, multiply that by 100, I'm going to get 2%. I think we got something a little higher than that. But no matter, this morning we still said it was unlikely. So technically, we did it a little bit different this morning, but we still got that it was unlikely, which is what we wanted it to be. Jonah has 3 red marbles, 2 blue marbles, 6 green marbles, 6 yellow marbles in a bag. If he draws a marble from a bag without looking, which color is he least likely to draw? Blue. Why?
That's the least amount of marbles.
I mean, that's a no-brainer, right? When rolling a fair number cube that is numbered 1 through 6, which event is impossible? All right, let's just think about a number cube first. Let's get some stuff in our head. First, a number cube is just a dice, right? So I can roll on a dice a 1, a 2, a 3, a 4, a 5, or a 6, right? Rolling an odd number. Can I get an odd number from here?
Yes.
So that, can I roll an even number?
Yes.
Can I roll a number less than 7?
Yes.
Can I roll a number greater than 6?
No.
I cannot, so that is the one that is least, that's impossible. Can I roll a 7? Yes, ma'am.
Can you send Devin Brooks to the front office for just a moment, please?
Yes, ma'am.
Thank you.
Can I roll a 7? Devin, come here, let me write your name. Can I roll a 7?
No.
No. All right. So, looking at number 4. I'll pull it up. Tamara, all right, go ahead and read number 4. Let me fill this out. Okay, number 4. See, this is what I like about this. I can scroll up and scroll down without clearing it. Is that cool or what?
That's cool.
And then I've got to, but here's the thing. All right, come on now, don't be silly. Oh gosh. Oh gosh, hang on.
Oh God.
Hang on, shh. Oh Lord.
It's putting a little dot.
I know. I'm writing on it. Just give me a minute, I can get it. All right, so look at number 4. Tamara is playing a game using the spinner shown. Tamara is playing. Oh, what in the world is going on? All right. No, I got it.
Your feet are supposed to be.
I got some big old feet.
I can't do that way.
It's okay. I'm gonna have to reopen it. There we go. Look, I just saved it, and then I reopened it. Now, Tamara is playing a game using the spinner shown. Which statement about the spinner is true?
D.
All right. The probability of the pointer landing on a green is 100%. Well, no, because there is.
More
All right.
than one color.
What is the probability of getting green?
25.
It would be 25% or 1/4, wouldn't it? Green is 1/4, which is 25%. So that's not it. Probability of it landing on purple.
0%.
That's a 0% because there is no purple. The probability of it landing on blue is equal to the probability of it landing on purple.
It's not
That's
even
not
a
part
purple.
of
There ain't a purple, so it can't be that. It has to be the probability of landing on yellow is equal to the probability of it landing on red. Those two sections are the same size, so that would be the same. If a fair number cube, okay, a fair number cube, that is just a regular old dice. A fair number cube is rolled 60 times. How many times will you most likely roll a 3?
20.
All right, now, here's the thing. This is a prediction, and we are using theoretical probability because we haven't done it, have we? What is the theoretical probability of rolling a 3 on a number cube? What is the probability of rolling a 3? The theoretical probability of rolling a 3? 1 out of 6. What should happen is I should get a 3 1 out of 6 times. But I'm going to roll it. I want to know how many times can I predict to get it out of 60. This is what I want out of all I have because we're doing theoretical. I want the number 3. There's 1 3 out of 6. Does that make sense? Everybody with me? Cross multiply, we get 60x. 6x equals 60. Divide both sides by 6. X equals 10. So my prediction is that 10 times I should get a 3 when I roll it 60 times. Okay? All right, number 6. Jared expected the arrow on the spinner to land on the space with the number 4 exactly 1 out of 4 times. He expected this to happen. He expected that to happen. That means that is the theoretical probability. He expected it to happen. He hadn't done it. He expected it to happen. That's theoretical. What you expect is going to happen. That's a good way to say that. All right? Which prediction, all right, so if we're using theoretical probability, what I want out of all I've got, land on the space with the number 4, the number 4, so what do I want? I want the number 4 out of all numbers. So how many 4s are there? Our expected probability is 1 out of 4, right? 1 out of 4 is your expected probability, and I want to know how many out of 48. So 4x equals 48. Divide both sides by 4, and x equals 12. So I should get it 12 times. Okay? Everybody get that?
Yes.
Alice's sock drawer contains the following pairs of socks: 2 red, 4 brown, 3 black, 1 gray, 2 white. If Alice randomly picks a pair of socks from the drawer, what is the probability the pair she chooses is not brown? Not brown. Now, this is theoretical probability. This is theoretical probability. This is what I want out of all I have. Okay? What do I want? I want a red. I want a black. I want a gray. Or a white out of all socks. Right? How many red are there?
2.
How many black? How many gray? And how many white? So that's a total of 8 socks. Out of all of the socks would be 12, right? 8 out of 12. Okay? On the flip side of this, let's go ahead and finish 8 and 9, and then I may come back and show you something later with that one. Victoria has a bag with orange, yellow, and blue chips in it. Without looking, Victoria reaches into the bag, moves the chip. She records the color and returns the chip to the bag. Performs this experiment 20 times. The table below shows the data. Based on the information in the table, how many orange chips should Victoria expect to select out of the bag after repeating this experiment 80 times? She's done an experiment. So we are going, this is experimental probability, but we've got to make a prediction. We're doing experimental probability and we're doing a prediction, okay? So, first we've got to have, if you remember, our prediction ratio, our proportion is we have We have a probability ratio over here and a prediction probability over here. Our probability ratio is going to be with these orange chips right here. And that's 9 out of 20. Right? And I want to know how many out of 80. 20 times x is 20x. Divide both sides by 20. That's not right. That's 72. I just had a moment. That's 720, not 720. Divide both sides by 20. And x equals 36.